Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University School of Engineering and Technology, SOET Diploma in Smart City Development and Management, DSCDM MIO5 Smart Cities, Safe Water, Sanitation, and Sustainability, Block-1 Water Supply in Smart Cities, Unit-4 Water Treatment for Smart Cities. 4.1 Objectives of treating the water. A. To make the water safe for drink, potable. For this all types of impurities like physical, chemical and biological must be removed. N. S. Varondoni, 2017 B. To make the water palatable, following parameters in water should be within permissible limits to make the water acceptable for drinking. N. S. Varondoni, 2017. Parameters: color, odor, taste, sediments and turbidity. Note: water quality regulations for drinking water are based on MCA maximum contaminant level, but wastewater standards are based on minimum degradation. 4.2 Classification of treatment units. Treatment units for treating the water are categorized into two parts. I. Unit operations. 2. Unit processes. I. Unit operations. Removal of impurities from the water by action of physical forces like screening and sedimentation. 2. Unit processes. Removal of impurities from the water by chemical disinfection, coagulation, for treating surface water, and biological action are used to treat the wastewater like trickling filter, activated sludge process, oxidation ponds. Screening. Purpose of screening is to remove the floating substances. Floating substances are removed by physical interception because they are larger in size than opening of screens. The aim of screening is to remove solid materials that can contaminate waterways, cause damage to other process equipment, cause reduction in efficiency of the whole system. Classification of screens. Screens are classified into three categories based on the size of their openings: fine screens, coarse screens, micro screens. Fine screen. Fine screens are used to remove fine solids from the incoming water. Opening of these screens are less than 6 mm. Fine screens may consist of wedge wire elements, wire cloth, and perforated plates. Fine screens are classified into three categories: A. Static, fixed, wedge wire screen. B. Rotary drum screen. And C. Step-type screen. A static wedge wire screen. These screens have I. Opening of 0.2 to 1.2 mm. 2. These screens are designed for a rate of flow of 400 to 1200 liters/m2 min of screen area. 3. To install these screens, larger flow area required and they need to be cleaned once or twice per day. B. Rotary drum screen. In drum screen, a straining medium is mounted on a cylinder which rotates in the flow channel. The water flows into end of drum and the outgoing water flows out through outer tooth. The screen with the solids are being collected on this interior or into top of the unit. C. Step-type screen. This screen made up of two step-shaped sets of thin vertical plates in which one plate is fixed and other plate is movable. These two plates are placed alternatively across the width of channel and they form a single screen face. The movable plate rotates in a vertical motion, hence the solids collected on the top of the screen face is carried to the next fixed step landing. In this way the solids is transported to the top of the screen to discharge into outlet. Coarse screen. Coarse screens are also called trash racks. These screens have opening of 6 to 150 mm. They are made up of wires, rods, wire mesh, parallel bars or a perforated plate having openings rectangular or circular shapes. These screens are sometimes placed in front of fine screens. Coarse screens are used to remove larger solids that may clog or cause any damage to other appurtenances. Coarse screens are classified into two categories based on the methods to clean them. A. Hand cleaned screens. B. Mechanically cleaned screens. A. Hand-cleaned screens. These screens are used in small pumping stations. They are also used as standby screens which provide service during high flow rate or when mechanically cleaned screens are under repair or during any power failure. The channels are designed to prevent the excess accumulation of grits, silts and metals. The screen channels should be designed in such a way that to prevent excessive accumulation of grit and other heavy metals. The screens are placed in such a way that channel should perpendicular to it so that it allows uniform distribution of solids on the surface of screens. B. Mechanically cleaned screens. These screens are designed to increase the efficiency of screening by reducing the problems related to maintenance and operating. These screens are classified into 4 parts. I. Chain-driven screens. These screens work as an automatic chain to clean the screen. It is classified into front chain-driven screens and back chain-driven screens based on how the raking of the screen from the upstream or in downstream and whether rakes return to the bottom of the bar screen from the front or back. 2. Reciprocating rake. These screens are also called climber screen. In these screens, rake first moves to the base of the screen and engaging the bars and then pulls the screenings into top of screen where these screenings are removed. In such screens only one rake is used which limits its capacity to handle the heavy load of screenings. 3. Catenary screen. In these screens, a rake is held against the rack by the weight of the chain. They are front cleaned, front return chain driven screen. If any heavy object is trapped in the bars, then rakes will pass over them. 4. Continuous belt screen. These screens are used to remove fine and coarse solids. They are continuous and self-cleaning. These screens have many numbers of rakes which are attached to the drive chains, and the number of screening elements mainly depends on depth of screen channel. Micro screens. These screens are rotating drum screens having speed of 4 revolutions per minute. These screens are continuously backwashed operating in gravity flow conditions. The openings of filtering fabrics is 10 to 35 micrometers and they are fitted on periphery of the drum. The influent enters through the drum lined with fabrics. The retained solids collected through backwashing and transported for disposal. Sedimentation. It is a unit operation in which inorganic suspended solids present in water is removed by action of the gravity. These tanks are designed to reduce the velocity of flowing water to give sufficient time to suspended particle to settle at the bottom of the tank. The efficiency of the tanks depends on the detention time period of the fluid mass after entering into the tank and before exit from tank. Davis, 2002. These tanks are rectangular or circular in shape. Suspended solids are having size of 10 m and greater and colloidal particles are of size between 1 nanometer and 1 micrometer. Condition for settling suspended particles. In a vertical flow, the settling velocity of particles must be greater than vertically ascending water velocity. In a longitudinal flow, the ratio of the length of the tank to the height of the tank, LH, is higher than the ratio of the water velocity to the limit. Sedimentation velocity. Settling of particle in sedimentation depends on size of particle, specific gravity of particle, viscosity of liquid, velocity of flow of water through tank and detention time. The relation between the settling velocity and the diameter of particle is explained by Stokes' law. According to this law, the settling velocity of particle is proportional to the square of diameter of that particle and is inversely proportional to viscosity of liquid. Settling velocity. It is the velocity of the smallest particle which will be completely removed in the tank. Thus all the particles having velocity greater than settling velocity will be 100% removed. Design of the tank. Let Q is the discharge and A is the cross-sectional area of the tank LBH/T. ABH. L length of the tank, B width of tank and H height of the tank discharge velocity, VF. TD is the horizontal flow and versus is the settling velocity, volume of tank LBH. Surface area pound. Velocity of flow equals Q/BH. Time of horizontal flow equals L/Q/BH equals LBH/Q equals volume of tank/discharge time of falling through depth, H equals H/versus. If versus is the settling velocity of particle, then it will be removed if the time of falling through will be equal to detention time. H/versus equals LBH/Q, then versus equals Q per pound. This quantity Q per pound can be known as the overflow rate. Efficiency of the sedimentation do not depend on the depth of tank. Formula for overflow rate, VO, equals flow of water, Q, M3/S, surface area of settling tank, IM2. This overflow rate is termed as surface loading in terms of M3/upper M2. In few countries, in case of weir, overflow rate is defined in terms of M3/upper M. The unit of overflow rate is M3/S. All those particles having with settling velocity, versus, more than the overflow rate will be completely removed. Types of settling in sedimentation tanks. Settling of particles are classified into 4 parts. All continuous flow settling. Basins are divided into 4 parts: inlet zone, settling zone, sludge zone and outlet zone. Inlet zone, water comes inside through its settling zone. Sedimentation occurs in this zone. Sludge zone, settled particles will be collected here. Outlet zone, water flows out through it. Controlling factors for sedimentation is different in all 4 cases. Type 1. Discrete settling. The particles does not change its shape, size and weight while settling. No interference occur between the particles, so each particle settle independently. Concentration of the particles in solution is lower than 500 mg/L. Discrete settling occur in suspension of low solid concentration. Example, this settling occurs in PST and grit chamber. Type 2. Flocculant settling. In this settling, interaction between the particles is made by adding certain the coagulants, hence their shape, size, and specific gravity increases and they clump together to form a solid mass and then a solid down. This settling does not occur by gravity, hence it is carried by providing suitable conditions artificially. This settling occur in clariflocculator and secondary sedimentation tank. Type 3. Zone settling. This settling occur in suspension of intermediate concentration of solids. Concentration of solids is huge, so field of settling is less, hence settling of particles are hindered or interfered by some other neighbor particles. This settling occur in lower depth of secondary sedimentation tank. Type 4. Compressed settling. This settling occurs in suspension of very high concentrations such that particles are come so close that they form a structure and then no any space is left for particle to move freely and settle. Particles are stacked forming a structure. Settling occurs by compression of the stacked particles due to their weight because new layer formed press the bottom layer. Coagulation. It is the process in which fine particles or dissolved particles are brought together by means of using certain coagulants to form a larger particle, and hence they settle down. Coagulant which are used of water, sludge volume, and some coagulants may cause bulking of sludge where removal of moisture becomes difficult. Swami and Sharma, 2008. Types of coagulants. I. Aluminium-based Al2SO43, LCl3, Na2Al2O4. 2. Iron-based FeCl3, FeCl2, Fe2SO4, PeSO4. 3. hydrated lime and magnesium carbonate. Factors affecting coagulation. The type of coagulant used. The quantity of the coagulant. The time of mixing and method of mixing. The characteristics of water such as temp, pH, type and concentration of impurities. Filtration. Filtration is one of the most important process in treating the water on the wastewater. In this process, water is passed through the filter medium to remove the impurities which were not removed in previous treatment units: screening, sedimentation and coagulation. Impurities like dissolved solids, colloidal particles are removed by filtration. Other impurities like color, odor and taste is also removed in the filtration. K. Idswald, 2011. In water treatment process. Slow sand filter. Rapid sand filter, pressure type and gravity type. The difference between these two filters is based on type of filter media, rate of filtration, heads required for filtration and method and frequency of cleaning. Various other biological treatment processes can use to treat wastewaters, such as septic tanks, MIO5 tanks, oxidation ponds, oxidation ditches. These treatment processes have long detention periods and sludge obtained from these processes are rich in nutrients and can be used for agriculture. When the sewage comes into direct, this leads to lot of troubles as soil sickness, fly nuisance and skin diseases. The unit operations and processes can be applied to individual units of houses, colonies and the industries that can cause minimum harm to the environment and can be handled with more efficiency. The unit operations that are incorporated in the water treatment plant depends on the source of water intake. Figure 4.2 and 4.3 shows a flow chart of processes that takes place when water source is lake/reservoir/river and a vale respectively. Figure 4.3 flow chart of water treatment plant for groundwaters. Look at the screen. For installing the treatment processes, following factors are taken into account. It should be installed at suitable distance from the residential area. Cost and maintenance of the treatment unit. Quantity and characteristics of the wastewater to be treated. Availability of resources nearby like water sources, electric power, supply, transportation. 4.3 Advanced water treatment options. Advanced water treatment used to remove the following impurities. To remove nutrients like N and P. To remove dissolved heavy metals. To remove refractory organics. To remove pathogens. To remove toxic substances. To meet the effluent standards of parameters. Various techniques used in advanced water treatment. Advanced oxidation process. Reverse osmosis. Microfiltration. Membrane filtration. Ion exchange. Electrodialysis. Adsorption. Air stripping. Advanced oxidation process ups are a set of chemical treatment procedures designed to remove organic materials present in water and wastewater by oxidation through reactions with hydroxyl radicals. Middle.O. Corp et al., 2019. Basic principle involved in UP is the production of hydroxyl radical O, which can be generated by oxidants like ozone, hydrogen peroxide and ultraviolet light. This O, hydroxyl radical, is highly reactive, is mainly responsible for the degradation. Reverse osmosis. It is a water purification process in which water is forced to flow from higher concentration to lower concentration through a semi-permeable membrane. It is used to demineralize or deionize the water to make it safe for drinking. This process also used to desalinate the ocean water to convert it into fresh and clean water. Reverse osmosis is also used to recycle the water to make it clean and safe again to use, and also is used in wastewater treatments. Membrane filtration. A membrane is a two-dimensional material used to separate the fluid components based on their size and electric charge. Capability of membrane is to allow only specific material to pass through it. It is physical process where separated components remain chemically unchanged. When apply pressure, water is forced to flow from higher conch to lower conch. This process is often used to improve quality of the food as it helps in separating the particles from water to create other beverages, such as beer, milk and juice. Membrane filtration classified into 4 categories. A. Reverse osmosis. B. Nanofiltration. C. Microfiltration. D. Ultrafiltration. Each filtration is used for different size particles. The particles found in salt water are the smallest in size, so to remove these particles, reverse osmosis is used. However, particles in river water may be larger, so this case, microfiltration is used. Table: the type of membrane, driving force and type of material retained. Look at the screen. Water oxidation: this process used to break the water into 2 components, oxygen and hydrogen. Thus, water is separated back to its original elements, and then these elements can be used for other purposes. As we all know, all the living beings need oxygen to survive, so this process can be used anywhere to fulfill the need of oxygen, such as filling the oxygen tanks. Global challenges like air pollution and climate change are currently harming the environment, so it's better to look for other sources of fuel, in which one is hydrogen. This treatment process provides water and hydrogen where it is needed to improve the environment as a whole. 4.4 Summary. The primary objective of the water treatment facility is to supply clean and safe water to the public which do not contain any harmful substances in it, free from odor or unpleasant taste, and which will not affect the human well-being. The whole process of cleaning the water received from various sources of water needs different types of treatment process in order to meet the permissible standards. Sometimes, due to the origin of the water source, i.e., groundwater or surface water, the unit operation may also differ. Since there is an increase in development in terms of industrial, agricultural, commercial, etc., the need of new technologies for achieving a better removal efficiencies have also increased. Most of these technologies are used when the water received at the treatment plants are highly contaminated, i.e., may be released from various industries. It proves to be very difficult to treat domestic as well as industrial wastewater together, or even only industrial wastewater using conventional methods. New technologies have proven to be competent enough that can really help in improving the quality of water which can be used by the industry for secondary process. Therefore, a proper treatment should be given to particular wastewater in order to meet the effluent disposal standards and thus save the environment from getting polluted. Thank you.